Okay, well, today's lesson is we're taking this from Polynomial Review Lesson number 5. We're solving polynomial equations. It's in this problem set we will have some complex factors, by the way, some complex solutions to our equations, meaning things with I in them. Let's go through the problems. This is our notes, so we're going to be doing these problems together. You should have your hand out, or at least a piece of binder paper with you, where we're going to be doing these problems. We've got 16 of them to do. So first of all, it's like move all the terms to one side and make sure it's set equal to 0. This is crucial. Never equal to anything other than 0. That is important because we're using the zero factor property, or the zero product property, that anything that multiplies to equal 0, well, the factors have to equal 0. So then you're going to factor the polynomial completely. And that means all the way through, not just to 2 factors, but as many as you possibly can. We're going to use a lot of our different factoring rules. We're going to set each of the factors equal to 0, solve each one of those to find the x values. Sometimes we're going to be using completing the square. Sometimes we're going to be using quadratic formula. We're going to be doing square roots, all these different skills that we've done throughout polynomials. So let's start doing some of these problems. For this first problem, it's already equal to 0. That's great. We're already all set for that. Now we're just going to factor out the x, and we end up with x times x squared plus 1. This whole thing equals 0. So I'm going to make this kind of like a little factor tree in this way. And I'm saying, oh, what would make x equal to 0? Well, when x is 0, that's that one. Here, we're going to set this one, x squared plus 1 equal to 0. To solve this, we would subtract both sides by 1, and we get x squared equals negative 1. And right there, that is the definition of I. And it's saying what squared would equal negative 1? Well, that would be positive. When we take the square roots of both sides, we get that either positive or negative I, because when you square positive or negative I, you get negative 1. And therefore, the solutions for this problem, we like to write these in solution sets. So we should write this that x is equal to, and it's good to use the set notation. And so we're going to use the parentheses here like this, x is equal to, and the answers are 0 and I and negative I. You can write plus or minus I. I like writing them all out so you can see that there are 3 zeros and it's a cubic. Now this next problem is not equaling 0, so we're going to subtract 3x squared from both sides. And when you subtract 3x squared from both sides, you get 4x cubed minus 10x squared equals 0. X squared can factor out, so can a 2. So we're going to take a 2x squared, and this times, and then when we factor it out, we get 2x minus 5. And that equals 0. So I'm going to, again, kind of make this like a factor tree thing here. And I say, oh, well, then I want to know when 2x squared equals 0. We would divide both sides by 2, and then take the square root of 0, and you get that x equals 0. Note that this is, if we were graphing, this is multiplicity of 2, because we had x squared equals 0. So this is a root, or a 0. It has a multiplicity of 2. On this side, we're going to take 2x minus 5 and have that equal to 0. We would we would add 5 to both sides and divide by 2, and you get that x is equal to positive 5 halves. And so your answer would be written in proper format. X is equal to the set of 0, 5 halves. Now, if I was doing this where I wanted to know multiplicity, you would say x, and then you write down below multiplicity of 2. Well, that's not necessary. We're just writing down our solutions here. For problem number 3. For problem number 3, we can see that this might not be apparent to you right now, but this is the difference of 2 squares. I can write this as x squared minus 8 squared, and that equals 0. That's one way to do the problem, and that's the way that I would probably approach this problem. Because then I can say, oh, okay, I could factor this out, and we're going to end up then with something else that we, what I mean is, you're going to end up with x squared plus 8 and x squared minus 8. You're going to get the conjugate pair, and that equals 0. So we could then take this and do it as a factor tree here. And some people say, well, you could have just added 64 to both sides, take the fourth roots. Fourth roots are harder for a lot of people to figure out. And so it's easier to do this factoring. That's what I was trying to get to earlier. Here we're going to set this equal to 0. X squared plus 8 equals 0. Subtract 8 from both sides, and you get x squared equals negative 8. Taking the square root of both sides, you get x equals, and if I'm going to have, I'll write it like this, it's plus or minus, and then the square root of negative 8. We need to take out that negative, and that's going to be x is equal to plus or minus, and the negative, what comes out is an I, and the square root of 8 is 2 root 2. So there's my two answers for this factor. For this other factor, we're going to add 8 to both sides. X is equal to 8. X squared is equal to 8. Taking the square root of both sides, I get x is equal to plus or minus 2 root 2. So my final answers are, whoops, not 8. X is equal to the set of, and because I'm missing, don't have enough space here, this is where I'm going to say, all right, let's just write that plus and minus. Plus or minus 2I root 2 and plus or minus 2 root 2. So there are 4 solutions there. The reason I don't like this as well is because it's harder to see that there's 4 solutions. It's okay though. It is acceptable to write it this way. Number 4, we're going to factor out the x and a 5, and we end up with 5x as one of our factors. And then we have x to the 4th minus 16, and that equals 0. Now remember, it said factor completely. This is the difference of 2 squares. The 2 squares are x squared that's being squared, and it is 4 that's being squared. So this factors again to 5x times the conjugate pair, x squared plus 4, and then x squared minus 4. And once again, we have the difference of 2 squares. So we're not done factoring yet. 5x times x squared plus 4 times x plus 2 times x minus 2, and that equals 0. And writing it like I kind of keep saying a factor tree or a T-table or whatever, however you want to word it. There I have them all, and say, oh, well, for this to be 0, I would say 5x equals 0. That happens when x equals 0. So I've solved that factor. Here I've got x squared plus 4 equals 0. X squared equals negative 4. Taking the square root of both sides, I get that x is equal to plus or minus 2i. Because the square root of negative 4 is plus or minus 2i. Then we're going to set x plus 2 equal to 0, and we get that x equals negative 2. And we're going to set x minus 2 equal to 0, and we get that x equals positive 2. So our answers, all 5 answers, because there happen to be, it's a 5th degree polynomial, and there are 5 answers. There's 1, 2, 3, 4, 5 of them. X is equal to 0. X is equal to positive or negative 2i. Negative 2, positive 2. I could have written negative or positive 2 for that, but I still had already written them out. Okay. Now we're going to move on to the next page. I'm going to briefly just go over some of these things here. I see that I have the sum of 2 cubes. In one of our previous review lessons, we went over, sorry, it's a little bit glary, we went over how to factor the sum or the difference of 2 cubes. So remember that this is the same thing as saying x cubed plus 5 cubed. That's what x cubed plus 125 is. Okay, let me see if I can. sure that that doesn't change. I don't know if that's going to help it or not. I think, let me just, down the brightness. Maybe that'll help. Okay. So the formula was for this, we see exactly what we've got, the x and the 5, x plus 5. And then we're going to multiply that times the first one squared, minus, since this is plus, this is minus, their product, 5x, plus the last one, 5 squared, 25. And that is going to equal 0. Now, one of the reasons this formula stops there is this trinomial is not factorable. This one is this is already factored. It's a linear expression. So we've got x plus 5 equals 0. Subtracting 5, we've got x equals 5. We've got one of our negative 5. Negative 5, sorry. Subtracted that 5. This one here is not factorable. When it's not factorable, we could do things, get all tricky and do completing the square or something of that nature, but I'm not going to do that. The thing that I like to go to is my quadratic formula. And so I've got 1x squared minus 5x plus 25 equals 0. My a is 1, my b is negative 5, my c is 25, and the quadratic formula is x is equal to the opposite of b, negative b, so that's negative 5, which is positive 5, plus or minus the square root of b squared, negative 5 squared, minus 4 times a, which is 1, times c, which is 25. All of that, the whole thing, over 2 times a, which is 1. So in this case, we've got x is equal to 5 plus or minus the square root of 25 minus 100 all over 2. And this is x is equal to 5 plus or minus the square root of negative 75, again, all over 2. I'm kind of running out of space here. And because I'm running out of space, I'm not going to write set notation. This is one of my zeros, and this is my other 2, but I have not finished simplifying that radical, that square root. Now remember that the square root of 75, the negative is going to be an I. So I'm going to say x is equal to 5 plus or minus. An I is going to come out of that because it's got the square root of a negative. The square root of 75. 75 happens to be 25 times 3. The square root of 25 is 5. And so I still have the square root of 3 left in there. And the whole thing is over 2. And that's a perfectly fine answer. It's not written in a plus bi format, but it's okay. Just leave it at that, showing that you can do the quadratic formula. All right? This next problem, we first need to subtract to make it equal 0. So we end up with 8x to the 5th. And then when you subtract 4x squared, we're going to get just 1x, so plus x squared equals 0. We're going to factor out an x squared, so we have x squared. That's being multiplied by 8x cubed plus 1. And you might not recognize that, but this is the sum of 2 cubes. And I'm going to write it up here. That happens to be 2x that's being cubed plus 1 that's being cubed. So we're going to factor once more to x squared times 2x plus 1, just what we saw there. And then we have the first one squared, 4x squared, minus their product, which is 2x, plus the last one squared, and all of that equals 0. And we have, once again, our little tree that we're going to do here. So this is going to be x. I'm just going to write x equals 0. I think we can get to that right now. That if x squared, then we know that when x is 0, we have that. Here I've got 2x plus 1. 2x plus 1 equals 0. So we would subtract 1 and divide by 2 and get x equals negative 1/2. For this one, we're going to need the quadratic formula. Since we've got 2x squared minus 2x plus 1 equals 0, you can see it all right there. My quadratic formula is x is equal to negative b, so positive 2, plus or minus the square root of b squared negative 2 squared minus 4 times a, which is 4, times c, which is 1, all over 2. I'm going to simplify that. We got x is equal to 2 plus or minus the square root. And use a calculator for this. I'm perfectly fine with that. Oh, I'm sorry. Let's go back. The denominator is 2 times a, and a was 4. We've got the square root here. Just you putting it in our calculator, you can get negative 12 all over 8. Okay, we're getting there. I'm going to move over here a little bit. X is equal to, we've got 2 plus or minus, and the square root of negative, we've got an I, and so the square root of 12 happens to be 4 times 3, which is 2 root 3, all over 8. Now this simplifies, because this is 2 over 8, and it is 2I root 3 over 8. So this time I'm going to write this out, what I would have. I'd have 2 over 8, which is 1/4, and I'd have 2 root 3 over 8, I'd have plus or minus 2 root 3 over 8 happens to be root 3 over 8 I. And so here are two solutions written in the format that I prefer, the A plus BI format. We have another solution right here, and we have our fifth solution, really. We got fourth and fifth solutions because there are 2 zeros here. So 0, negative 1/2, and this complex number. All right. I want you to start thinking about the difference of 2 cubes, looking at greatest common factor before you even begin the problem, setting it equal to 0 already, but looking at this looks like a quadratic. We're going to get all of our fourth degree on one side, and then we could do this as the difference of 2 squares. We're going to look at that. I want you to try these 4 problems, come back, and we'll see where we are. All right, so here's problem number 7 and 8. Let's see, I used the quadratic formula for both of those. Number 8, I had to do, I looked and noticed that there was a common factor first to make it simpler, and then I had difference of 2 cubes. For number 9, I see that as a quadratic, so I factored it like I did a quadratic, but then I ended up, I mean, it's not really a quadratic, but it looks like it because this is the middle term squared, so we can factor it like we did with quadratics. We did grouping. And we have those solutions. And number 10, getting everything on one side equals 0, factoring out the common factor of 10. You can only do that when the common factor is numeric, because you can't divide by x because you don't know what x is. It could be 0. So that's through problem number 10. And then our last sheet of our notes, we've got 11, 12, 13, 14, 15, 16. And so we look at these, and there's a variety of different ones. I'd like you to look at them, try them, and I'm just going to show you the answers to them. So do, look at the problems, pause the video, attempt doing them, start the video, and kind of look to when I'm posting the answers, okay? Okay, for the first 2 on this last sheet, we factored out the x, and then we have a quadratic. Factoring that out, we have our solutions. Now there are 3 solutions, but one of them is a multiplicity of 2. Number 12, we factored out 2x squared, and we have what appears, it's a trinomial, it's 3 terms, and it's kind of like a quadratic, and we just factor that out like we would a quadratic. X squared minus 8 times x squared plus 3 gives us that trinomial. Solving for each one of those groups, we get those 5 answers, knowing that 2 of our zeros are at 0, so that's why it's a multiplicity. So we only see 5 numbers, even though it's a 6th degree polynomial. For numbers 13 and 14, both of those are done. They're treating them like quadratics, and I'm using if you need to pause it to look at this again, I'm using that slide, divide, and then bottoms up method that I slid the coefficient. And I have it written in pink here because this is not the true quadratic, but it's what we're using. And so I factored that quadratic. Then I divided it by what we slid and simplified. When I couldn't simplify, I bring the bottoms up. So this trinomial here, this 4th degree trinomial, factors to this group here. And I used in pink the slide, divide, and bottoms up method. And then I solved for both of those factors when they would equal 0. I used that same method here for number 14, where I slid the 5, and now I'm faking it with this other trinomial, factored that, and then when I divide and bottoms up, you divide and I can simplify when I can, and I bottoms up when I cannot simplify. And in blue here you can see that I have the factored form of this trinomial. And then I solve for each of those factors when those factors equal 0. The last 2 problems are done by factoring, by grouping. I think of that because there's 4 terms. It's a quartic and 3rd degree quartic. So I grouped them in 2s and found a common factor. And then a common factor between those 2 terms. Then in these groups, there's a common factor of x plus 2 and what was left. And then I factored that out and I have the solutions there. And this other problem was also a factor by grouping. And I ended up with the difference of 2 squares where we have to factor it all the way. And I ended up with the solutions, okay? So that's the end of this lesson. Now remember, you're going to do the handout that goes with this. And starting next week, we will be using Apex for our practice. And the lessons, the videos will be much shorter than these since it's not just, here's how you fill out a worksheet, okay? And I will see you next week during our Zoom class, but also don't forget to message me any questions you have.